expand the notification zip file that is there, you'll find this directory that has the processing files for handling the notifications and like an example sketch that uses that engine. And there's some example data in there that's a JSON file. And when we look at it here, is that readable? Do I need to make that bigger for you? So here's an example set of events. And so you can see that there's going to be events of communications of different types. All of the different parameters are specified here, including the most important is the timestamp. So what this notification engine does is it ingests this JSON file and then dispatches the events at the right time. So you don't have to worry about any of that. You just use that engine. So your sonification system will just receive events at the right time and you respond to them. You can see all the different parameters here. And it'll be your choice how these parameters affect the sonification that you're going to play for it. You also notice, to make this possible to debug, the timestamps are really fast. Because if this was realistic, it'd be like, you run this, and after 20 minutes, you get an email. And then like 2 minutes later, you get a voicemail. So these are all like really fast. And it's designed such that you'll have flurries of events that all come in at once, which is realistic, right? At any one time, we're probably, out of all these things, you're probably simultaneously, you're often getting things simultaneously. And in particular, we want to explore those sort of scenarios. Like, what do you do when you get 3 emails at once and your mom has called you 4 times in the last minute? Like, how does this sonification engine work? How does it create something that isn't just overwhelming and super annoying? All right, so these JSON events come in, the notification engine will dispatch them. And so the decisions you're going to make are, 1, how do I schedule whatever it is I'm going to play, when am I going to schedule that? So the most obvious thing to do, and the thing that will get you like a 70 on this project is, okay, every time an event comes in, I'm just going to play a sound. And you'll quickly realize that that is horrible. Because, especially given the temporal nature of sound, you'll be in the middle of like reading out an email subject line, and then like tweet alerts are playing, and then it starts playing a different text-to-speech thing about a text message you just got, and it's just this cacophony. And so you've got to figure out, when am I going to play these things? And you're going to want to consider all of these factors, like what was the priority of this message that came in? What was the type of this message that came in? What else is currently going on? What is the current status of the system? Is it in the middle of playing something that's high priority already? Or was it in the middle of playing a bunch of really low priority tweet information? So you got to figure out when, it could be some of this stuff is so kind of low priority or low interest that maybe you just wait. And maybe you even aggregate information. So like the tweets are a really good example of that, right? Unless you're some sort of internet influencer, you probably don't care that much about what is happening, on your Twitter feed. So maybe what it does is just like counts up like the number of interesting tweets, and at some set rate, it might just inform you either through speech or through non-speech audio, like, there's been a bunch of retweets of your stuff here in the past hour, right? Another decision you're going to make is about the actual sonification scheme for each individual event. And how are you going to convey these different different parameters through your sound. So again, if you're wanting to get like a C on this project, all you'll do is it will just play like set auditory icons for each event. So, tweet, tweet. Oh, I got it. I must have gotten a tweet. Ding! I must have gotten a missed phone call. You know, doo-doo. I must have gotten a text message. That's like a very binary sort of cue. It's not telling me anything more. It's not really helping me figure out. Like, if you tell me, if I can tell, oh, I got a whole bunch of emails, who cares? That could just be a bunch of mailing, Georgia Tech mailing list emails. Or it could be something incredibly important that I need to take action on, right? I mean, I get missed calls all the time. Like, most of them are those, like, spammy phone calls, right? So just telling me, oh, you have a bunch of missed calls, that doesn't help me make any decisions. But if I find out, oh, it's a bunch of missed calls from Scott, or it's a bunch of missed calls from my daughter's daycare, you know, or from the doctor, or whatever, like, those are, that information really helps me make decisions. So a really good project is going to dynamically modify the sound based on these different parameters. And so a key requirement is you have to play all the events at some point in one of the contexts. Yeah?
Do you mean like make the volume greater or
whatever, I mean, that's sonification, right? It could be any of the parameters of the sound. It could be that a super high priority thing, you play a beep beep ahead of it to tell me that it's important, and then you play tweet tweet to let me know that it's a tweet. You could make it louder, you could change the pitch, you could have different alarms. You know, it could be like tweet tweet for a boring tweet and like chirp chirp for something that's really important, right? I mean, that's why there is a creative aspect to this homework that you have to figure out. But it's really about dynamically modifying and about representing, trying to capture. Now, you don't need to try to capture all the parameters all the time, every time you render an event. It really matters, if you look back at that nomadic radio paper, it really matters about the type of information and the priority of it. If it's a super high priority, if it's the most high priority email, I might want to use text-to-speech to read out the subject line. But if it's really low priority, I probably don't want to hear that. Maybe just a little non-speech audio cue. So another one of the decisions that you'll make with your sonification is when to use text-to-speech. So that's the other thing that we've provided you. So there's already a text-to-speech engine that we've given you. And the way it works is you send it a parameter of like text that you want it to render. It creates a WAV file. It puts the WAV file in the data directory. So then you have to play that WAV file. But it's pretty easy to use. A very bad project is going to only use text-to-speech because it's easy. But it's also horrible, right? So the most horrible project that will probably get like a 6 would be, it doesn't do any scheduling of the events, it plays all the events, it mainly uses text-to-speech, and so what you're just in this like horrific like Black Mirror world of like this robot voice talking over itself all the time. So you want to use text-to-speech sparingly, but you are required to use it, and you should use it, because I mean, in the right cases, it's very useful. All right, so then another big aspect you have to figure out is the mixing. And this is kind of related to the scheduling. So you've got to figure out, you've got to remember, you've got to not just think about it like there are these individual events. You have a whole ecosystem of information that's coming in. And so how many events do you want to play at the same time, or do you want to have things overlap? What happens when you need to interrupt one thing for another, right? So a common approach that a better project would use is that you'll create some sort of priority queue. So a weak project just takes the events, just plays them, and then forgets them. A more sophisticated project, as these events come in, will put them in this queue. And the exact scheme that you use, that's up to you. I mean, one approach would be, all right, I'm just going to pop them onto the front of the queue, except when a priority 1 thing comes in. Like priority 1 things always are at the front. I mean, so you could be sorting based on priority, but the downside of that would be low priority stuff might literally never play. So it's like, maybe there's like an expiration time. So if something has been waiting for too long, I go ahead and play it. But once you get into this, you start to realize this is getting complicated. Because like, what if it's time to play the aggregate low priority tweet stuff, but oh my goodness, it's already in the middle of playing a really high priority thing, right? So you want to make sure that everything does get played eventually. But you certainly don't want low priority high priority things languishing for a really long time without being played. What happens when you need to interrupt? So maybe I'm in the middle of playing something. Do I just shut it off? Do I pause it? So like maybe it's in the middle of telling me about these tweets and like, oh my goodness, it's like a call from the doctor. Does it pause the tweet thing and then play the doctor call and then go back to playing the tweet? Does it just duck? So duck is the term where you have a bunch of audio clips playing at the same time and you like lower the volume on some of them and raise volume on the other. So you could play them all at the same time, but you could lower the volume of the tweet and play the high priority thing loudly. You could just stop the tweet thing altogether and just never come back to it. You could get really clever. So some of the questions here again are about ducking versus pausing. You could also try filtering to support the mixing. So maybe if I have a low priority thing playing already, maybe I do a low pass filter. Or maybe it's like harder to make out, but it's still playing, and then I'm hearing the higher priority thing instead. So again, these are all design decisions. There isn't a right answer, but you want a system that does all of these things well, whatever your scheme is. And well means it's not a whole bunch of stuff playing all at the same time and you don't know what's going on. I mean, the rubric for you should be, when you sit there and debug this thing and listen to it, can you stand listening to it? If you're like, oh my God, I have to turn this on. If your roommates are like, what is happening in there? You're doing a poor job. Like, sometimes when we're grading these, like our spouses will be like, what are you doing? It's like, there's like a baby crying and a siren going off and, I'm like, well, the sound design decisions here, can be a little better.
I will say that to help us grade it, please do a thorough write-up, including like your decisions for the scheduling and the aggregation and
Right.
the sonification scheme, what you did and why you did it.
Yes,
That
yeah.
helps us understand.
Right,
We're
yeah,
not,
so
we're not going to be training with the system for hours to learn.
Right. Yeah, and that's a really good point. So a really great way of raising your grade is putting the time into your design document to explain how your stuff works. Because we're looking through all this code. It's a lot to kind of take in. If you explain why you did it, and sometimes I've initially listened to someone's project, and I'm like, I don't really know why they did that. I don't know that I agree with that choice. Then when I read the document, I'm like, okay, I get where they were coming from. Like, they've convinced me. All right, but now there's one other rich in the works here. Because there's another input to all of this, which is context. So how you do all of these things is going to be changed by whatever your current context is. So recall that I walked through that you're required to handle these four different contexts. You're riding in public transit, you're like jogging outside, you're at a party, or you're giving a lecture. Obviously, I would want a different sonification scheme while I'm lecturing than I do when I'm running, right? Like, I'm much more interruptible when I'm running, I'm probably bored, I have a lot of cognitive resources that I wouldn't mind devoting. That's actually maybe a good opportunity to kind of review my communications and catch up on what's happening, whereas when I'm lecturing, it is not. And so you've got to consider both the individual's kind of their cognitive state that they're in, as well as how interruptible they are. And you also need to consider the physical environment that they're in. And it's like the very subtle sonification scheme that I use while you're lecturing, which might be just some little like clicks or like a little sort of sound, would not be good for when I'm out running. I probably wouldn't even be able to hear those cues. All right. Questions? Yeah.
Actually, just going off of what you just said, do you think it would be a good idea to prevent capacity rate totally request for high priority and then let like a low, it's not a low priority, since if you're running, you only want to be in high priority.
See, I don't agree. When I'm running, I'm just already listening to podcasts and music and stuff. I would rather hear it. For me, that would be a time when I would be interested in hearing low priority things, because I don't have anything else going on. But that's part of your justification. If when you're running, you're in that mode, okay, you can argue that. But this is, to be clear, don't argue that you never want to hear anything ever to make the project easier. We pick up on that. It's very clear when the design decisions were, because this was way easier because it's 3 o'clock in the morning. I mean, I get it, I've been there, but okay, so I think it'll be more clear. Let's walk through where the grading, where the points come from, and then I think that'll really help you understand what you're going to be creating. All right, so what are you writing? Well, you're going to be writing this right here. You know, like, now, to be able to test your system, we need a user interface so that we can quickly try out different scenarios. So some of these early, like easy to get points are for the UI. So you're going to have some sort of screen. Now remember, this interface is not for the user. This is just like a test interface for us to grade and for you to be able to debug. So don't make it with the idea that this is something the user would ever be interacting with. Like, in reality, the user interface for it would be, you know, some sort of mobile thing or a smartwatch thing. And don't put any time into this UI. We've had students that make these beautiful interfaces. It doesn't matter at all. You're not going to get any points for that. If you have time to spare, spend it on your sound design. So you just need to have some buttons on this UI that let us test different scenarios of your sonification engine. So you're going to have some context buttons that let you pick these different contexts that you might be in. Jogging, public transit, party, lecturing. When you click those, it's going to, you know, inform the sonification engine, hey, this is the current context that we're in, and all of this other stuff will change accordingly. Also, to help us kind of judge like how good the actual sound design is, when you click this button, you should also play a background soundtrack of that environment. And you don't need to spend any time making that good. Go to freesound.org and you'll find there'll be some 3-minute loop of like cocktail party or chemistry lecture or, you know, person running outside. But the idea is that when you click that, I'll immediately then hear like the sounds of a party. There's like music, people talking and glasses clinking. And then we'll be able to judge, can I hear all of these cues over that background soundtrack? But so don't spend a lot of time on that background soundtrack, but it is critical that you do it. Yeah?
Just to clarify, so we're making a system with basically no user input at all?
No,
from the user,
no.
just from the tester. Okay.
Right. All right, so you get your 7 points just for doing that. You've got the context buttons, they play the background ambient audio, and it triggers stuff in your engine. Then you're going to have some a radio or checkboxes for the information types. This is also for debugging and for grading. It lets us turn on and off different events. So there's one for each information type. And so if I want, I can turn everything off except tweets and just listen to how did you render the tweets, right? Or how did you render the voicemails? It'll make it really easy for you because it is kind of overwhelming. Like when there's a bunch of stuff happening in these event files, it can be really hard to debug. You're like, did that actually play? Or like, why did I not hear that? So it really is handy to be able to just like turn sets of things on and off. Please have, yeah.
Is that like resetting the entire time clock?
No, it's just saying like, only respond to Twitter right now, or only respond to voicemail and emails. Please have all of these checked by default. I know it sounds silly, but we grade 70 of these. For some reason, a lot of people default to having none of them checked. So every time we load the rest of the project, we have to like check all of them, or have a button that's like all on. That would be nice too. All right, so when someone is choosing those, it's just going to determine which of these, when these events come in from the notification engine, do you pay attention to them or not? Okay, so I mentioned last time this idea of a status sound. Because remember, if I don't have a visual display, or there's not one that's readily available, it makes it really hard for me to know whether the thing is working or not. It's like, am I not hearing anything because I'm not getting any communications, or I'm not hearing anything because the battery's dead, or doesn't have a network connection. So there's going to be a button, and when you hit it, it's going to use it's going to sonify information about this made-up battery power and made-up network connectivity. And so you're going to have like a slider, a couple of sliders, where you set that manually. So we can quickly experiment with like, what does it sound like when they have no network but the battery's at 3/4? What happens when it's out of battery and it has good network connectivity? And so it should play some sort of sound or a couple of sounds that it conveys what that status information is. Yes?
So just to clarify, so if this was playing, there's like a background going on, and you check some types, so things are, things are being played. So then if you as the tester like move both your sliders, would it do anything until you click status?
It shouldn't do anything until you hit status.
Okay.
Yeah. Cool. And it should just play it. You don't have to like schedule the status sound. It should just play over whatever it's already.
Okay, cool.
And it would be nice if it'll play even when nothing else is going on, like if you haven't loaded any event. So you also can load the different event files. So there should be 3 buttons for the different types of events. There's 3 event JSON files. So when I click one, it should restart that file, and it should load that file and start sending the events from the beginning. And it should let me like hot swap it. Like I shouldn't have to stop the app and run it again to switch between event streams. So I'm listening to 1, and then I'm like, okay, well, let me hear 2, and I click 2, and it starts from the beginning of 2. I listen to that for a while. I can click 3, it starts from the beginning of 3. Okay, so that's like the really easy points right there. Just kind of basic functionality. So then here, requirement 5, the system does real-time sonification of the data from the event stream. So these points are less subjective. Like maybe your sounds are really bad, and that's okay for those points, but you will get those points if, when events come in, you play sounds based on those events, and those sounds are dynamically modified in real time based on the parameters of the communication. Now, you don't have to render all the parameters all the time for every type. So you might say, well, there's all of these parameters for related to tweets. Maybe you wouldn't want to hear about all this information for every tweet, but maybe only for the highest priority tweets. And it doesn't mean that you have to like read out with text-to-speech the number of favorites. It could be like, you know, if the favorites are between 0 and 10, you hear like one sound, and if it's between, you know, if it's more than 1,000, you hear another sound. So you don't need to do information overload, but again, don't avoid sonifying the parameters to make the project easier. So make your design decision based on like legitimate kind of belief about what people would want to hear. Generally, for every event, no matter the type, people will sonify something that tells you about what type it is, something that tells you its priority, because that's kind of the most important. You know, for something like email or text message or, well, I mean, for a lot of these, the sender is pretty important. I mean, especially if it's like a high priority thing. So anyway, those are the decisions that you'll make. But those points about sonifying data, you get those by having dynamic sounds that change based on those parameters. Then there's a big chunk of points here for this sonification engine. So this is kind of this part of it. So you could get all these points if you were just playing sounds when events came in. The sonification engine is more about the scheduling, the aggregation, the mixing, like how are you deciding when to do these sounds? How are you handling multiple sounds playing at the same time? Yes?
Is there any info, like can we look through the JSON files to see like what events that the user may have a higher priority than others? Like, can you see if like the text message from mom might be a higher priority than like say a text message from some dude named Jay? Like,
I mean, you could totally do that. You do not have to do that. I mean, in general, your solution should kind of be agnostic of the event, example events, but that would be kind of a next level thing where you kind of had some heuristics, like, yeah, mom would probably, even if it's low priority, if it's for mom, I might want to have like an additional like way that I sonify the sound, and that would be great. That would really be pushing it to a better grade. Yeah.
my other question was, when we're working on this, we can always come into office hours and ask.
Oh, yeah, of course. Okay, absolutely. Please. No one from this class comes to my office hours. My other class that they all come, so please come see me. And Scott, and Ben. So, and an aspect of this 25 points too is that this engine is changing its behavior based on the context. So that's the key thing, that when I switch from lecturing to being at a party, the behavior of the sonification engine changes itself, including how you sonify these sounds. You know, when I'm lecturing, I might only play the most high priority things, and I might do kind of a very simplistic sort of like that. Because even if it's high priority, the person probably doesn't want to start to hear a bunch of text to speech, right? Versus what you might want to hear like while you're riding on the bus. All right, so some little points that you should make sure not to throw away. You need to utilize both auditory icons and ear cons. And we put this in here just to try to push you to kind of explore different sound design approaches, right? So, you know, ear cons are more abstract. They don't necessarily sound, there's no metaphor that's like linking the sound to the event. Whereas auditory icons mimic real world sounds. I mean, it's easy enough to get these points, and you can argue, just in your document, kind of point out like, this is what I consider an auditory icon, this is what I consider an ear con. Mainly, we don't want you to like just go to free sound and just like download like a phone ringing and a bird tweeting, and the sound of someone typing on the keyboard. Like, usually, like the status sound is usually really abstract, so that's a good opportunity to like do an ear con. Similarly, you have to have at least one sound that is generated in code, that it's not a WAV file that you're playing. You are using like a waveform in B, so you're generating like some basic, you know, waveform. It's like a sine wave, a square wave. Maybe you're doing some amplitude modulation, but you're creating that sound in code and playing it. Oftentimes people do that with a status message. So, you know, based on the battery level and the networking level, they'll do like some simple amplitude modulation with 2 sine waves or something like that.
Yeah, that means using a wave player. You have to
Yeah,
do it.
right.
No.
Yeah, use the wave player in beats. And you also have to use text-to-speech, which is easy enough because we've already given you the code to do it. But don't only use text-to-speech. And when I say use text-to-speech, use it to render these events. Because I did have a couple of people that they never use text-to-speech except when you click on a button, it would read the label of the button, which is not the spirit of that requirement at all. So, and there's no reason to do that because it's easy, it's easy to do. All right, so then we get into some of these subjective points. There's going to be 10 points that are around the quality of your individual sonifications. Like, do they sound good? They're not like making me wince in pain when I hear it. Can I detect the changes in it? Like, maybe you explain, like, well, I changed the pitch of this clip based on the content. Can I hear that? Can I actually understand it? So, the short version are your individual sonifications like well designed? And then there's another set of 10 points that are about how do they mix together? Do you have a nice audio ecology? So a bad version would be you've got some 8-bit chiptune sounding, arcade noises mixed in with like some very realistic auditory icons recorded. Like, so don't have it, you've got mail, and then like beep boop, and then like a violin playing, and like it doesn't fit together. Like look at casinos. They do a fantastic job of creating an audio ecology. All of those machines in a casino, their individual devices making their own sounds, but it all mixes together and it makes this like kind of hypnotizing soundtrack, right? That you just kind of like puts you into some sort of trance. Do all of these sounds work together well, like thematically, in terms of frequencies that they use, in terms of volume? So you don't want to have like some clips that are just mysteriously like really loud and other things that are really soft. So you're going to want to like normalize your clips. If you are changing the volume, it needs to be based on some sonification scheme. Like, well, it gets louder when it's higher priority. Right. So those to go from like a C to getting a really good grade, you need to put a lot of care and thought into the actual sound design. All right, and then to conclude, you are going to have this design document. There isn't like a length requirement. As I've said before, everyone will just play games to have a length requirement. The font's a little bigger, or is it double spaced? I don't care. The point